Hello and welcome to this DCD talk, the first of 2025, where we'll be addressing resilience in network design. Joining me for this discussion, I'm delighted to welcome Takai Eddine Kennouche, AI architect for Viavi Solutions. How are you doing?
I'm doing well. Yeah. Hi, Alex. Yeah. Nice to talk to you again.
Nice to talk to you. Well, thank you for joining us in the DCD studio. By way of introduction, Taki, perhaps you could give us a little bit more context to your role and your career journey so far. How did you come to work at Viavi Solutions?
Oh, yeah. Okay. Well, my background is in telecommunications. Has been a very interesting journey transitioning from the stuff I did throughout my academic career to what I'm doing right now in Viavi Solutions. So I started as by doing a master's degree studying wireless communication networks, more particularly wireless sensor networks. Heavily focused on implementing simulation and emulation capabilities to model these kind of networks. Did a PhD in also electrical and computer engineering with a focus on communication systems. And I played around a lot with software-defined radio systems, explored the space of cognitive radio, basically smart spectrum management and heterogeneous networks coexistence problems. So we worked on DLT Wi-Fi coexistence problems when it was all the rage back in the days. And yeah, throughout this journey, you get to find a lot of interesting complex problems to solve in the networking area, right? And AI ML is kind of, became a fascinating, say, set of tools to reason about, understand, and address some of these problems. So at some point, I made a decision that I need to focus heavily on exploring AI ML applications to solve difficult and challenging telco space problems. Hence, me joining Viavi Solutions exactly to pursue this journey as my role as a research scientist slash engineer, and then as a lead architect working on finding use cases, finding new architectural patterns of rendering these use cases into products, and then operationalizing solutions in a manner that helps our customers and helps our company basically solve the right problems in the right manner. Yeah.
And when it comes to VRV, as you mentioned, you're trying to solve problems in the right manner. But to come to the question at hand when it comes to resilience and network design, it's an age-old problem. But how has this changed in context of AI? Are we seeing new definitions for resilience and reliability? And what's the role of VRV here?
That's absolutely. This is a spot-on question, and I think a major concern right now. So Viavi Solutions, we build systems and products and hardware solutions, software solutions to address various network performance, reliability, resilience issues, right? I mean, we build a range of test and measurement equipment to make sure that what gets deployed is actually ready for deployment and will not harm or diminish the value to be extracted from an operational network. So, and we are recognized for these kind of solutions that we provide the large telco and communications industry, right? So resiliency for us is extremely important because that's what we would like to get our customers to reach: resilient, reliable, efficient, and monetizable networks. I wouldn't say that AML redefines any notion in this regard. I think it exacerbates existing notions, exacerbates the importance of addressing these concerns, right? To give you an example, um, the rise of disaggregation communication network in the past, maybe discussion has exploded in the last couple of years, right? Through maybe the ORAN discussions and even within 3GPP, right? This raised concerns about how do we manage interoperability issues and how do we manage the softwareization of a lot of network components. So this is the conversation around the resiliency of the networks against the failing or the mismanagement of certain aspects of this increasingly softwareized and complex networks existed. So that's a question of resiliency. What happens when some part of the network fails to deliver the expected reliability? Will the network just dies and the humans have to intervene, or are there mechanisms for it to continue its operations? So AML comes to the question to exacerbate these concerns in the sense that it's no longer about making sure to do an integration test or functional test offline before deploying its software capability. The problem is the capability in itself is almost like a living being. It's a data-driven entity where its behavior and its function cannot be to perfection quantified in the lab and then deployed with understood reliability characteristics that will kind of be perpetual, right? So you end up in a situation where while the capability is live in the system, you need to expect at some moment the conditions of the systems to lead it to fail. And we call these failure modes of AI, ML, models, right? So there are failure modes that are understood in the machine learning space and literature that we cannot ignore when we deal with highly sensitive and extremely crucial systems and infrastructure such as data centers or telecommunication network systems as well. Yeah.
Mhm. Brilliant. And I would, in terms of, the other benefits and challenges, I think it's probably a little bit reductive to ask you what are the pros and cons here. Obviously there's quite a lot of hurdles to overcome, but that's why we have partnerships, we have
Yeah.
solutions to help drive this. But we talk about AI a lot as a workload, but we don't necessarily always discuss it as a tool. I guess with that in mind,
Hmm.
how are Viavi kind of leveraging AI to, make sure that it is being beneficial to the networks as well as just something we have to manage and capacity plan for?
I mean, I would say there are three high-level kind of maybe buckets from which to approach this question of yours. I think there is, of course, the question of the overarching question is resiliency. But there is, of course, the first bucket, which is how do you make sure you test the capabilities with the right approach that is fit for the system under test, knowing that in this particular case, the system under test is a system driven, maybe sometimes primarily by an AML model, right? Data driven capability where you train something and then you integrate in a system, and that becomes your network system that you want to test before you deploy in a live network. So we have of course, a range of traditional test and measurement capabilities in this space, and we are fully aware of the importance of uh, rethinking or augmenting these capabilities with approaches and processes that are fit for AML. For example, exploring adversarial testing is an important topic. You know that machine learning models can be made to make the wrong predictions if you are going to trigger them with a carefully crafted input. So the question is, what kind of a carefully crafted input you can create in a test environment so that you in the lab trigger the model to show you its failure modes, the moments where it will fail. So it's better to know them in the lab before you know them in the field. And transitioning these testing methodology to the field, because you also recognize that no matter how extensively you test, it is a data-driven process. Ultimately, live in the network, there will be moments where maybe the model, hence the system it is operating, will be presented with maybe randomly crafted or even adversarially in a bad actor kind of way crafted inputs that would also trigger it to fail, right? That would be extremely bad thing. So we're talking here about bringing certain test methodology from the lab to the field through a continuous testing approach. And here we talk a lot about how digital twinning solutions could help you have an ability to test capabilities live in the network by isolating them in a digital twin environment, subjecting them to extensive and quite aggressive testing vectors to make them fail so that they fail in a digital twin rather than they fail in the network. Right? So it's extremely powerful. The other bucket is the bucket of monitoring. A lot of what we're talking about here to impose resiliency upon a network is your ability to observe your network in all its facets and through all of its components, topology, KPIs, changes, etc., etc. So you need to have a holistic view about this network. And I mean, of course, there is the notion of an AI ops. So how can you employ artificial intelligence to effectively define network characteristics, explore topology, and fix the crucial problems for any database system, which is data quality. And it's very often in telecommunications networks that the network elements that are generating the observable data to you, they might fail here and there, are misconfigured, don't report what they should be. So there is a serious issue of the network presenting itself in an incomplete manner. But you, in order to make data-driven decisions about how to better manage the network, you need as good data as possible. So you need to go out of your way to complete that picture, and AML helps a lot in completing this interpolation, extrapolation capabilities, graph modeling, and topological search in the network, and discovering which network elements are missing from a particular view. These are all important capabilities that we help our customers deploy and provide throughout their networks. The third and last bucket is the optimization bucket. You're going to have to, of course, you collect the data, observe the system is operating. Hopefully, components are tested properly and continuously tested. But ultimately, you need to manage this network in a data-driven manner and make optimization decisions that factor in the multifaceted views of the network, right? You need to factor in the fact that your wireless RAN subsystem of the large network is actually strongly coupled in performance to the backhaul fiber powered network. So when you make a decision policy to optimize a certain aspect, it will be tremendously helpful for you to know that that the backbone or the backhaul of your RAN radio access network have identified the trends and identified the issues that could be factored in to decide how do you scale down or up, and how do you commission a new site, and where do you send your technicians to do the most important, the most impactful troubleshooting or diagnosis work, right? So, and AML plays a large role here as well for us, and we help our customers go into the journey of deploying these kind of capabilities.
Brilliant, thank you. Just to kind of jump on an example when it comes to LLMs, I'm interested to kind of think about, the application again,
Oh, yeah.
particularly when it comes to training versus inferencing workloads. Obviously there's going to be different network requirements for different workloads, but what are the kind of key differentials there, and how do those kind of phases of large language models look for kind of network and network testing, network monitoring?
Yeah, I mean, yeah. So of course I'm an AI enthusiast as well, not just an architect. So I mean, I love everything that is new, recent, and shiny and cool. And I jumped on the AI, ML, generative AI wave as well, and it's fascinating. A lot of amazing things happening. But I mean, from from a real world point of view, we approach this from the perspective that ultimately what we're looking for is the best tool to solve real world problems that have an impact. So we do regard, I think I like to regard generative AI as yet another tool with quite impressive qualities, but again, with quirks that we need to be aware of in the larger theme of resiliency that we were talking about. I don't want to be putting in anybody's network random capabilities that I cannot quantify their behavior. I can't understand their failure modes. That's not going to be a wise thing to do business wise. So, from that perspective, large language models have some interesting emerging, I believe, dynamics that are particular to the notion of training a very super large model that requires a heavy investment to build, and then you're going to have to deploy it to do inference across a wide range of tasks, because that's the purpose of training that model. The dynamic that I find extremely interesting is this dynamic between training and inference. I think we have seen in the last year or so that the training burden, the burden of training multi-billion dollar parameter models, massively scalable, I mean, massively huge, big models, has been delegated primarily to quite specific players in the field. I'm talking about the OpenAI, AWS, Microsoft, and XII players in this space, while the usage and the use case developer community has leveraged this very well in an inference mode, where you can get this pre-trained model and you build quite impressive use cases around the fact that you can just fine tune, maybe you can maybe prompt engineer, you can design interesting wrappers, sometimes just wrappers around publicly available APIs, right? So this is very interesting dynamic. And another nuance of this dynamic is the concept of inference as a service. A lot of companies I think, are positioning themselves from this perspective of you don't really, in many cases, really need to train everything from scratch. It's going to be so costly, forbiddingly costly, I would say, for most telecom players. So, but you can do a lot if you can interface with inference as a service infrastructure with high-speed chips deployed in the cloud, exposed through APIs, and they host the latest and greatest of generative AI models, large language models, and they provide a service to the industry where you could just submit queries of predictions, and then you get your predictions for a fee that is a function of how many tokens you generate and consume. This is a very interesting dynamic that I think is quite profound and fundamental for bringing to the market innovative capabilities in a fast-paced manner and leveraging continuously the latest and greatest, because every week basically there is a brand new large language model that defeats everybody else. So this is very interesting dynamic. And as players in the telecommunication industry, I think it's important for us not to get lost in the weeds of generative AI. It's fine. I think exploring the fundamentals of that and how generative AI is built is a kind of a nurturing journey. But from an operationalization point of view, we might not want to get lost in the weeds and leverage inference as a service and this interesting dynamic that is flourishing right now with the continuously decreasing costs of inference to be able to bring to market fundamental and quite powerful applications in a speedy manner. Yeah.
Very nice. My final question. We are running down the clock, unfortunately. But in light of these models, further innovations when it comes to AI, how can we make sure that organizations are still prioritizing testing, and data-driven decision making to ensure reliability throughout their networks and network infrastructure as they scale?
Yeah, proof points. So we like to generate a lot of proof points. We are, as a company, for example, we are in standardization organizations. We are speaking loud about the importance of testing and defining what testing means and testability criteria for various system components in a disaggregated world and heavily AML powered world. The importance of embedding industry proven ML ops, data ops, DevOps practices in the manner with which we deploy and manage our traditional telecommunications networks, having changed the mindset around what it means to operate such a complex networks, and maybe learning a thing or two from data centers and the other type of networks that historically have leveraged more extensively AML capabilities. So testing is extremely key, and I think as we start this conversation with resiliency as a notion that is quite different from reliability and efficiency definitely needs to be explored from the perspective of how do I ascertain that the capabilities that I'm deploying the network will together build for me a reliable, continuously reliable network. And once some of these components fail, because AML ultimately will fail, there are failure modes and the failure will happen, that failure does not render the whole network basically a big, massive failure. So I want that resiliency and self-healing capabilities, the ability to mitigate failure modes from embedding AML in the network. Yeah.
Very nice. Well, Taki, thank you so much for your time today. To our audience, thank you very much for tuning in. If you've got any questions, please do reach out to Taki and the wider team at Viavi Solutions. But thank you again.